Hello everyone and welcome back to our week 12 session 2 on the application of natural product databases. Now in the previous session we learned that we could use some of the natural product databases to help us gain more information about certain plants. So if you remember this, we saw the plants of World Online, Jastor, Tropicos as well as the New York Botanical Garden herbariums. There we raised in a query of certain plants, and then what we saw is whenever you raise a query, the softwares come back with herbariums, they come back with the taxonomic information, they come back with the geographical information, and some of them also come up with the therapeutic application. With that, we also saw in the previous session that there are certain servers which help us with the traditional medicinal drug. Now there are numerous such servers, softwares available globally. Like I said, some of them are paid, some of them are free, but we saw a few freewares which were particularly relevant to Indian traditional system of medicine. This included our TKDL, that is Traditional Knowledge Digital Library. This included our IMPPAT, which included the Indian Medicinal Plants Phytochemistry and Therapeutics database, as well as we also saw the Indian Medicinal Plants database. Now in this three, what we saw was not only that they gave us details about the plant, their geography, but they also gave us the details about the traditional knowledge, the places where they are used, the systems where they are used, how they are used, in which formulations they are used, what is the script written or the shlokas written about them. In today's session, we will further move a step ahead and we will see softwares which are going to help with phytochemical search. Now many a time it so happens that I have finalized my plant. Now once I finalize my plant, how do I know what all phytoconstituents it contains? Now many a times people resort to traditional techniques. Now traditional techniques, we also saw some of the quality control techniques. So you will pick up that plant, say for example ashwagandha, and start analyzing, does it contain steroid, does it contain flavonoids, does it contain triterpenoids, and so on. But nowadays you need not go there. The reason is there are certain software, servers or web platforms which are created to help you already collect the phytochemical information which is there on the global database. So these servers will collect that information and give you curated list of phytoconstituents present in a plant. So you already know that if it is ashwagandha, it has to have this many substances. If it is a ginger, it has to have this many substances. So instead of going paper by paper, textbook by textbook, this particular softwares that we discuss in this session or this particular web-based servers that we discuss in the sessions are kind of going to help us find the phytochemicals and also to certain extent tell us about the properties of them. So what are these softwares? We will see a few softwares which includes Dr. Duke's phytochemical and ethnobotanical database, Knapsack, that is a database of comprehensive species metabolite relationship database. Then you have PhytoHub, which is more pertaining to food, but many of the plants that we are already using are being used in food. So that will also help us find some important plants in that region. Then you have the coconut database. It's nothing to do with coconut, it's just an abbreviated form, that is the collection of open natural products. Then again you have the IMPPAT. We saw last time itself that it also gives us the depth about the phytochemicals, plants as well as their therapeutic actions. In addition to that, the NIST Institute, which is present in the northeast, also has curated what is called as a OSADI database, which is online structural analytics based databases, especially for herbs in India. So let's try our hands on few of these servers and let's see how each of these servers respond to us with the list of phytoconstituents when we give them a plant. So let's take a look at how do we access them. So the first database that we see today is the one which is developed by USDA, and that is Dr. Duke's phytochemical as well as ethnobotanical database. Now if you see this, when you click on the link to this database, you will end up with a search page. Now this search page, you can filter whatever you require. Are you searching for phytochemicals, biological activity, plant, a syndrome, or ethnobotanical, especially traditional medicine based activity, or a ethnobotanical plant. Now just for a convenience, let us keep this at any, and then let's put any of our query. Say for example, I'll put a simple case of clover, or let's put clove for example, and then I search. So you will see that when I put clove as a query, now you can see there are certain boxes, and in that boxes there are alphabets. So A box indicates biological activity, C indicates the chemical entity, E whether it is a ethnobotanical plant, plant depth, syndrome, or ethnobotany. So majority of the queries have returned us with the list of constituents. So you can see clove contains, and you can see here about 4 compounds that are reported through this database. Then there are plants which are called as clove. So you can see there are so many plants which are called as clove. Okay. And then these are kind of ethnobotanical plants, and if you see here, just a plant which is called as. So these are the traditional one, these are the modern one. So I'll just click on Syzygium aromaticum, and then when I click on Syzygium aromaticum, I am specifically scientifically going to the clove that we want. See, when I put clove, it could be clove of anything, and that's why the database was very non-specific in finding out. Now when I put specifically Syzygium aromaticum, you can see what happens here. So now it has come across with list of few compounds, and they are numerous. So you can see the number of pages. Now what is this activity count is in literature how many activities have been reported for this particular compound, which plant part it occurs, and the reference possibly for the report of this compound. Now you will see that some of them are still star, that means no clear mention of that is there. In some cases you might see the concentrations also being reported. Many a places when the server is not able to find it, in that case it is not reported. You can see eugenol, acetyl eugenol. So many of them are terpenoids if you go to see. So I am just making you run through what all compounds it can contain and see. If you were to manually search this many compounds, how much time you would invest in collecting the list. Now one thing about this database is this database also gives you the minerals, the amino acids, the primary sugars which are present. So you might come across like aluminum, ascorbic acid, or certain times even amino acids or proteins which have been characterized from this plant. So just imagine your all literature search pertaining to phytochemicals present in clove is done within seconds for you. It's an enormous list. I can download this result as an Excel sheet and then just paste it for my report or any further studies. So say for example, it has come out with around thousands of this. So this thousands can be nicely downloaded as an Excel sheet and then copy pasted wherever you want. You can see here. So whole of those pages that we were seeing, many of them are repeats also with a spelling mistake, because of that they might be there, and some of them are different plant parts because of which they are repeat. So about say zonarin, you can see the repeat is because the different flower part, one is in flower, one is in fruit. So those also, so you come across with almost 352 entries herein. So I will not save this. Going back, similarly I can search for any other plants and I can put even the specific query. So of that, what compounds were in terms of a particular activity, I can do a search there. Now we move on to the next database. The next database is a knapsack database. Okay. Now when you put in the knapsack database, you come across this as a landing page. Knapsack actually sources information from many servers. Here are few of these servers from where it actually kind of picks up the information. And whenever you want to search, you can actually download a version or you can just do an online search. So we will just do a online search. We are not looking for anything particularly, we will just put a plant and again let us put a clove. So you can see versus your Dr. Duke's database, here we are looking for a word which is clove. Let me put the query as ginger and then say list. So you can see in terms of ginger, it comes back with compounds, molecular formula, Cas ID, but compare that with your Dr. Duke's database, this does not give you any information about the plant part. So this is your knapsack, and knapsack specifically gives you information about the phytoconstituents in terms of their list and molecular weight. Comparatively, if you see as compared to Dr. Duke's developed by USDA gives you more elaborated list of phytochemicals. Moving on to the next software, the next software is PhytoHerb. Now PhytoHerb, if you go to see, is a software which will give you a different perspective. Now this is more pertaining to food. So when you click on PhytoHerb, PhytoHerb will give you this landing page, and PhytoHerb is a software pertaining to phytochemicals but predominantly occurring in food sources. So you can search them by compound search. You can just see any of the compound and click it. So it will give you the properties, like it's a terpenoidal family, but here like I said, more predominantly it gives you an elaborate thing about the food. So here you can see in terms of food, I can just click on almond, say for example, and it will come across few compounds that are reported in almond with structure, and you can have publications and other details of that. You can also have set of related metabolites and if at all biomarkers of intake. You can also go to the search page and you can do a basic search there. Let us say for example formula search. Let me just put say for example glucose formula or something like a carbohydrate formula. So if I know my compound, I know my molecular formula, whatever compounds are present in this database along with the same molecular formula, it presents there. So I can do my structure search, LCMS, GCMS search and so on. Now the next software is the one we already have seen. You remember the phytochemical search. So in this case, I can just put my phytochemical name, or I can put my plant name. So let us see phytochemical name, and you can see this eugenol is present in so many plants. So there are almost 1300 entries. So if I have to say quercetin, if I have to say rutin, if I have to say eugenol, and I have to find back which all plant contain them, IMPPAT is a good software that will give me this kind of data. Not only does it give me eugenol, it also gives me the derivatives of eugenol. So I can just be, it can be a name or it can be a part of the name also. So this is where it helps me, and I can get a huge number of entries, and I can come up with the number of plants which will contain eugenol. Now I can also do a plant search. I'll erase this query. I'm just putting ossimum. So you can see ossimum is your tulsi, but ossimum you have numerous compounds. So it will give you the list of all compounds which are present in all ossimum species, and that's why the search queries have gone to as high as page number 374. I can be more specific. Let's say for example, let me put this one, Africanum. So this time it will end up with only those phytoconstituents which are present in Ossimum africanum. So if you see the other Ossimum santum or Tenuliflorium, again you have as high as 60 searches. So depending upon which plant you are searching and how many compounds this database has, it will get you everything here. Now one more database what we can see a phytoconstituent is a Oshadi database, which is developed by NIST. Okay, so this gives you a whole what is called as pan-India database of medicinal plants, which includes the traditional knowledge, geographical classification as well as phytochemical information. So when you are searching on this, we can do search on this, say for example traditional knowledge, and I just click on one. So it will tell you what it is scientific name, where it is used traditionally, say for example dysentery, where it is available geographically and how it is used. So extract is taken orally. Just going back there, let's say for example, if you remember in your tannins, Acacia catechu. So Acacia catechu, again the taxonomy, where all in India it is available, what all phytochemicals does it contain, elements cured by Acacia catechu, the plant parts as well as the vernacular names. So I can use this database to find out detail about any traditional plant herein with respect to most of its things. You can just click Aconit. So you can see here Jammu and Kashmir, Madhya Pradesh. So that's where your Aconitum is found out. So you can have the stem or the roots taken orally, and these are all the therapeutic implications of this used in the traditional medicine. Now moving on to the next tab, you can go by geographical classification. Say for example, I want to know what all plants grow in Meghalaya region. So you can see the list of plants which have been found in Meghalaya is updated. So if I want to see geographically also what grows here, I can just click on that particular plant, and again the same details are available, but I can search state wise. I can also do a phytochemical database search. So say for example, I want to see Vitexin. So the database will come up with a solution to that. So you can see Vitexin, this is the plant where it can be found, this is the IUPAC name, the PubChem and the details. So let's search a common phytochemical, say for example Camphorol. So again Ficus carica is where it is found. This is what is called as the IUPAC name, the 2D version which is referred to as the canonical smiles, the INCI abbreviation, the PubChem ID as well as the regular smiles of that. You can also search one more database which gives us the detail about phytoconstituents along with the structure, and that is your coconut database. So I am just clicking on this query which is already saved here, and that is your Papaver somniferum. So if I see Papaver somniferum, it will come across what all compounds it contains along with the structure. and I click on this, I again come up with the details, canonical smiles, synonyms, chemical class, alkaloids, especially the aporphine category. These are your tyrosine alkaloids. You see, you get a lot of details here, as well as the papers in which they are cited, databases in which they are found, the molecular properties, especially how many atoms it contains, how many heavy atoms, how many rotatable bonds, how many amount of rings, what is the charge, does it contain sugar, how much it is more of a natural product likeness, that is how good is it as natural. It is definitely a natural product, and hence the score is like more than 1. Then total polar surface area, log P, which gives you a kind of lipophilicity index. So you will get different properties of this compound as well from your coconut databases. So just quickly summarizing this. So now what we saw is, in addition to our previous database which told us about the plants, as well as therapeutic databases which told us about the pharmacological activity, especially of the traditional medicines, in today's session we saw databases which will give us the list of phytoconstituent. So you can search the plant, you can search the traditional application, and once you are done with that, you search or curate a list of compounds which are present in it. This softwares, especially Dr. Duke's database, Knapsack database, PhytoHub, Coconut, IMPPAT, as well as Oshery databases are going to help you curate that list of phytoconstituents. Many a time you might see overlap between the databases, but sometimes some of the databases will come up with an add-on compounds. So you kind of consolidate them and come up with a new curated overall list. Still, many of these softwares are at developmental stages, and as a result you will see many of them incomplete in terms of their information. But yes, as they develop, more and more compounds are being added to this. So this databases are being updated on the regular basis, and you can keep on checking them to update your list for the medicinal plant that you are interested in. So thank you everyone. Here are few references that you could check forward, which I will be sharing, and then thank you for your time. Keep on searching these queries with the plant that you are interested in, and see what information these databases have to offer about the plant of your interest. Thank you.